Let's take a look at how to use a graphing calculator to find the model of a function. So in this first example, they gave us a table of values. So I am going to add it into Desmos. So over here in Desmos, I'm going to click this plus sign right here to add a table. Then I'm going to type in the X values and the Y values that I was given in the table. So I'm going to put -1, 0, 1, 2, 3. Then 0.6, 2.05, 5.8, 18.5, and 53. And I can see that my graph looks exponential. So in order to write the function that models the table of values, I'm going to type in a regression equation. So y needs a subscript of 1 because it needs to pair with what I've told Desmos, which is that my input values are x sub 1 and my output values are y sub 1. So I've got to tell it that I want y sub 1, and it's an approximation, so I need the sign that means approximately. And then exponential form is the a, b, and then you need to have an exponent of x, and then you need to make sure it has a subscript of 1 again, because that goes with the x values you've told Desmos in your table. So this will give us an exponential model for our function. So you take the values of a and b that they give you in Desmos, and you write out your function in exponential form. So our model will look like y equals a times b to the x power. We no longer need the approximation symbol because now we have our equation. So I can write out y equals a, which it says 2.13. So let's just round that off. So 2.13 times b, which is 2.92. And then the x for your exponent. Then it says evaluate for x equals 5. So you can do just plugging it in, or you can also do your table of values and get it that way. So there's two different ways. Let me show you both. So if I just plug it in, I say 2.13 times 2.92 to the 5th power. So I would just type that in, 2.13 times 2.92 to the 5th power. And I get approximately, because I'm rounding it off, 452.16. The other way you could do it is you could type in your model of your function. So I could type y equals the 2.13 times 2.92. Take away the 5 and put back your x, and then bring up a table of values. And we can put in the 5 for the x, and notice we get the same thing that way. And that's more helpful if you need more than one value of your output given your input or so forth. So both ways are great. The next set of steps is if you use the TI-83 or TI-84 calculator, which is another way that you can get the same equation. So I'm just showing you Desmos on here, but we can also use these steps in the graphing calculator. Let's look at number 2. It gives us some more data points, so we need to clear out what we've got and type those in. So I'm going to take everything away, and I'm going to use my add a table function and type these values in. So I've got -3, -2, and Desmos starts to pick up on the pattern if there is one, so it intuitively figured out what I needed next, which is nice. And then I have 192, 96, 48, 24, 12, 6, and 3. Then you can look at your data and tell that it's going down, and it appears to be exponential decay. So what we can do to write out the model of this function is the same thing we did before. So I need to put in the next row in Desmos, y sub 1, then scoot over and put approximately m x sub 1. Oh, wait a minute, I'm doing linear. Let me back up. I need a times b to the x sub 1 power. So we can do any regression equation we need. We just need it exponential because our graph of our scatter plot looks exponential. So let's write out our exponential model using the a and the b that we now have found with Desmos. So y equals 24 is the a times b, which was 0.5 to the x power. To evaluate the function for x equals 6, we can just plug in x equals 6. So in the next row, I'm just going to type in 24 times 0.5 to the 6th power. And now we get 0.375. All right, let's look at number 3. What exponential function best describes the following points? So let's clear out what we've got, add another table, and type these in. So they're just in a list of ordered pairs, but I need to type the x's first in the x column. So I see -1, 0, 1, and 2. And then the y values, I see are 4/5, 4, 20, and 100. They're just written a little differently than a table, but it means the same thing. So 4/5, 4, 20, and 100. They've already told me that they needed the exponential function, so there's no guessing what we need. We can just go right to type in that one in. So y subscript 1, again, that's because you're asking it for a model of the data that you've put into Desmos, which you have called your input x sub 1, y sub 1. So that's why those are really important subscripts. So that way they communicate with one another. And then we have a times b to the x sub 1 power. So it's exponential form, but you just got to type it in a way that looks like a regression model. And then we have a equals 4 and b equals 5 that's given to us with Desmos. So let's write that out. Our model would be y equals 4 times 5 to the x power. Then it says evaluate the function for x equals 4, so we can just plug in the 4, or you could use your table, but plugging it in is a little quicker when you just need one value. So that's why I'm doing it that way for the ones that have just asked us for one thing. We can just plug it right in. So I got 2,500 for that one. Now let's look at 2 more quick examples. If we are determining the rate of growth and decay and initial values from a function, it says without graphing, determine whether each function represents an exponential growth or decay. Also find the percent or rate of increase or decrease. And what is the initial value? All right, so I see 100 is definitely our initial value. So I'm going to write that out. And then if we were to rewrite this function to show more of the rate, I see that this is less than 1. So I need to think of how much less than 1 is 0.12. So I know it's a decay function. So I know I need 1 minus. So you could do 1 minus 0.12 to figure it out. And you get 0.88 would be the difference. So I need to say 1 minus 0.88 to the x power. And then I can see my rate of decay is 0.88. And 0.88 is 88%. So if we wanted to change it to a percent, we could multiply it by 100 or move the decimal over 2 places. And you want to move it back over to the right. Let's look at one more of those. So they said, what is the initial value? So that in this case is just the 0.2. So I'm going to write that out. The initial value equals 0.2. Then let's rewrite this function and think about what would be the way to write the rate so we could see it. So 5 is bigger than 1. You want to think of that as that's definitely growth. And how much bigger than 1 would 5 be? So 5 is equivalent to 1 plus 4. Well, then 4, that's a big rate of growth. That would be a rate of 4, which if you move your decimal over, we've got to say that that is actually 400%. You can multiply it by 100 or move it over to the right 2 places. All right, so that's it for this lesson on exponential model.